Okay, now we're on to spheres. So we're going to do the volume and surface area of a sphere in the same lesson. So sphere is the set of all points in space. So set of all points in space, so going in any direction in space that are a given distance from a given point. So again, you have that center point and then you have a radius, but this radius can go in any direction. So, and that you can imagine that hitting the outside of the sphere, but the radius can go in any direction. Okay, so the formula for the volume of a sphere is this crazy formula, 4/3 pi r cubed. Now, big hint, you have r cubed here, radius cubed. That means you're going to have 3 dimensions. And you're, of course, going to have units cubed when you're doing the volume. Okay, a little side note on where that comes from. So this isn't on your packet or your sheet, but just going through where this comes from. If we have a hemisphere with a radius of r, so I'll just draw a hemisphere like that, and then it has a radius of r, is filled with water. So the volume is represented by the water. The water is then poured into a cylinder. So I'm going to draw the cylinder over here. So it's poured into a cylinder, also with a radius of r. And then I'm going to make the height of this 2r, because that would be the height of a sphere, if you can imagine there was a sphere. Okay, because this would be r and that would be r. So this sphere would fit right into the cylinder perfectly. Okay, guess what fraction of the cylinder is filled? So again, if we do a hemisphere and pour it into the cylinder, the cylinder would be filled 1/3 of the way. So that 1/3 comes back up again. Okay, so if I pour in a sphere would be 2/3 full. So if I pour in the whole sphere into here, this cylinder would be 2/3 full. So what that brings up is the volume of the sphere inside this cylinder would be 2/3 base area times the cylinder height, which is 2r. So 2/3 pi r squared times 2r. That is how you represent the volume of a sphere in this particular situation. Okay, but if you put all that together, this 2 multiplied by the 2/3 will get you the 4/3. You still have the pi, and then r squared times r is where the r third comes from. So this is just a basic explanation of sort of how you can imagine that formula came about. You actually do need much higher level math to prove where that comes from. Okay, so just practicing with that, we're just going to use the formula. So find the volume of the sphere below. So obviously we have r is equal to 4. So the volume is 4/3 pi, and then 4 to the third. Okay, 4 to the third, you can do that in the calculator. You can do 4 times 4 times 4, or you can use the caret button. So on your calculator, there's like this little caret like that. So 4 caret 3 does 4 to the third for you. Okay, but 4 to the third is going to be 64. And then multiplying this out, you multiply by the top number, divide by the bottom. So 4 times 64 is 256 over 3. This does not make our rational number. Well, it's a never-ending decimal, so we're just going to leave it as this fraction. 256 over 3 pi, and then units, of course, is to the third. Okay, so pause and try this one on your own, same way. Okay, welcome back. So you're going to have 4/3 pi, 6 cubed. Okay, 6 cubed is 216 times 4 divided by 3, and you do end up with 288 pi inches cubed. Okay, next one, find the volume here. So obviously we have a composite figure, And the two pieces are a hemisphere, and we have a cylinder. Okay, again, writing it out in either pictures or words is a good way to start the problem-solving process. All right, so here we have a radius of 12 that would also apply to the hemisphere here, and the cylinder has a height of 30. Hemisphere, so obviously that is going to be 1/2 of 4/3 pi r cubed. Okay, and then the cylinder, like usual, you do base area times that perpendicular height. Okay, so that's just filling out all the formula information. Well, here, 1/2 of 4/3, it should make sense that if you do 1/2 of 4/3, that is going to be 2/3. So a hemisphere formula is 2/3 pi and then r cubed. 12 cubed here, again, you can use your calculator, is 1,728. And then over here, obviously, you get 144 pi, and then times that 30. All right, putting this together, you're going to multiply by 2, divide by 3. You should, in your calculator, get 1,152 pi. 144 times the 30 is 4,320 pi. All right, these both have pi, so they are like terms. So you can combine like terms. So my final answer is going to be 5,472 pi, and that is feet cubed. Okay, next. Surface area. So you actually watched how baseballs were made as an introduction to surface area. So surface area formula is 4 pi r squared. I'm actually going to go over to my little baseball picture here to talk about how you can remember that. So in that video, from time 1:40 to 2 minutes, in that time frame, it shows you the pieces that they cut out of the leather. So they look like this, but there's actually 2 of these. So there's another one that you can imagine kind of lays this direction. And what you do is you take the ends here and you wrap them around, and then you take these ends here and you wrap them around, and those 2 pieces of leather will form the baseball, and they stitch them together. So this is a little bit of a stretch, but as you can see, do it with the highlighter, as you can see, in a very, very rough way, you have 4 circles. These 4 circles will wrap together to form the ball. So that's how you can remember the 4 pi r squared for a sphere. Okay, and obviously we need much higher level math to actually prove why that works, but this is just a visual to help you remember the 4 pi r squared. Okay, so find the surface area of a sphere with a diameter. So be very careful that you read carefully on that. So I have my sphere. You just put a little belt on a circle, and that gives it that 3-dimensional feel to it. But I have a diameter of 5. So that means my radius is 5/2. Okay, so the surface area is 4 pi and then 5/2 squared. So when you're squaring a fraction, you square the top and the bottom. So I get 4 pi times 25/4. And then with multiplying the 4 times 25/4, these will cancel. So you simply get 25 pi. And then again, that would be a square unit. So 25 pi feet squared. Okay, so pause and try number 2 on your own. So welcome back. You should get a radius this time of 8. So the surface area is 4 pi 8 squared. So that one's fairly easy. 64 times the 4, which is, what, 256? Yeah. Pi, and then units is again squared. Okay, when you were doing a hemisphere, you do have to be careful with surface area. Surface area is always a little harder than the volume. So hemisphere, you have to imagine that you can pick the thing up. Let me go to here. So you can pick this up and touch the base. So you have half of the sphere, the curved part, but then you create a base that you can also touch. So you do have to be careful that you include that circular base. Okay, so for a hemisphere, you can think of this as half the sphere, and sorry, this is for surface area, is half the sphere, but then you have to add on that circular base. So hemisphere surface area, because you can pick it up and touch the base, is going to be 2 pi r squared for this, plus another pi r squared. So you get a total of 3 pi r squared. Okay, so hemisphere surface area is actually 3 pi r squared. So in this particular case, you have 3 pi and then 9 squared. So 81 times 9, you get 243 pi, and that would be meters squared. Okay, last one is actually the hardest one. Again, this is problem solving using your formulas. You are finding the surface area, but you are given the volume. So always, always, always start with your given. So I'm given a volume of, and this is for a sphere, 36 pi. That's all I have. So I have to use that information, and as soon as I have that given information, I'm going to set it equal to the formula. So the volume is 36 pi, so I set that equal to 4/3 pi r cubed. Okay. Solving for that, again, I don't know what this is going to do for me quite yet, but I'm going to solve this because that's all I know. So divide by pi on both sides. Those are going to cancel. And then algebraically, you are going to multiply by 3 and then divide by 4. If you divide by 4, you could do it in your head. So 36 divided by 4 is 9. 9 times 3 is 27. So I get 27 is equal to r cubed. All right, so this is your first introduction into a cubed root. So calculators have different options. If you need help figuring out where your cubed root is, I will help you with that in class. But you are going to take the cubed root of both sides. Basically, you want to think of a number where if you did it times itself 3 times, you get 27. In this case, that is going to be 3. So 3 times 3 is 9, times 3 is 27. So I have a radius of 3. Okay, so now I'm going to draw myself a lovely picture. And I have a radius of 3. Well, once I have a radius of 3, then I can figure out the surface area, because the formula for surface area only involves a radius. Okay, so I'm going to plug that in. I get 3 squared. And then that's 9 times 4, which is 36 pi. And that would be centimeters squared. Now, let me clarify. I'm sure some of you are noticing, well, oh, the volume here was 36 pi. The surface area here was 36 pi. Wow, that would be really easy if that would always happen. Doesn't always happen. So you do have to actually calculate. Just for this particular sphere, this is how it works. This does not always happen. That would be lovely if it did, but it doesn't. Okay, well, there is your spheres. I will see you next time.